Gregor Ottosson, and Gregor used to present several times in decision camps before, and it's always his presentation were not only highly meaningful and specific, and at least I really like them. And what is interesting that probably we will have a good continuation on previous discussion, because when Gregor presented last time, he used to be a lead AI specialist in IBM. And then he started his own AI company, Cube5, and it's already probably several years old and has very specific results. So this is a kind of independent opinion and real world practice could be shared by Gregor. And Gregor, everything is yours. Go ahead.
Perfect. Thank you very much, Jacob, and happy to be back presenting again here and sharing some things. So I wanted to collect and share some learnings from a few projects we've been working on this year that are sort of right in between of what I would say classical decision management projects and purely new AI project. There's somewhere in the middle, and I want to share what we've learned from those. So what I'll do is I'll give a quick intro just to level set. I'll dive into these three different systems or projects or use cases, financial reporting, high-tech manufacturing, and educational. So they're very diverse, and you will see that. And then in the end, I'll try to, the hardest part is actually trying to summarize and kind of take a step back, but I'll do my best, and maybe that will be a good kind of conversation at the end to discuss some of this. So the key question I'm trying to answer by looking at this project is, when is it better to model our data, our knowledge, our processes, our decisions, that what we have been doing for so many years? And when should we just throw it over the fence and let Gen AI work directly on the source content, the documents or whatever the information resides in? That's the question I've been pondering. All this, but I'll try to highlight a couple of things here. So what I'm looking at is two crude buckets of technologies. The traditional technologies where we have procedural code, declarative models, symbolic AI, all the stuff that we've been working with for 50, 60 plus years now. And on the right-hand side, kind of the new tool, the new tool on the block, if you will, generative AI, large language models, plus all the side technologies like RAG and agentic and so forth. I'm not going to go through all this stuff. I think we largely agree on their different characteristics. Just highlight one thing. One key distinction for me is that the way we work in the traditional way is that we design time. We define our schemas, our models, our ontologies, etc. That could be database schemas, it can be decision models, process models, whatever. Whereas if you just use purely Gen AI approach, you don't do that. You kind of occasionally, you might have the LLM invent the schema on the fly dynamically, and we'll see that in two of the use cases here. But you don't give that as input typically. There are exceptions, but in the cases I'm talking about today, that's the case. The other thing is that I'll try to say symbolic AI or probabilistic AI, but I'm going to forget because the rest of the world has decided that AI means generative AI. So if I say AI without any prefix, I mean large language models and that right-hand side thing. So forgive me for that. For many decades now, we've been basically building computing systems, applications, and so forth by structuring things. We take input from the outside world and we represent that. Initially, it was, it was just data structures, lists, arrays. Then it was data models, database schemas. In the last few decades, it's been decision models and process models. And we've used that to represent kind of the world, right? And the world has lots of things around it. Increasingly now with generative AI and large language models, it's easier for us to semi-automatically start understanding or reading or analyzing the source documents that could be of a variety of different things, of course. And bringing that in is easier than before. So there's two things we can do. One is we can use that design time, right? We can use an LLM to extract policy from a policy document, or extract a database schema from a table in a document or something like that. So in essence, we can use LLM's design time to expand our models. Our database schemas can be fuller, our decision models can be more granular, our process model can be more detailed, right? So our green sphere here becomes larger. And you'll see I'll try to use the green as the color for the traditional approach, right? Which now has become better. The other thing we can do is we can just throw it at the large language model. We can just give him the whole document, or at least pieces of the document, and do document-centric probabilistic analysis through prompts, ask our questions. And I'm going to tease out something, we kind of know that, at least my opinion is that on the right-hand side, the traditional approach with declarative modeling is still best for any kind of calculation, approvals, compliance, and routing. If you need 100%, this goes back to the prior conversation between Tom and Pierre. If you want kind of reliability, robustness, determinism, these are classic use cases, and largely I think they'll stay there for a while. On the other extreme, you have a bunch of new use cases, right? LLMs are fantastic for translation, extraction, generation, conversations. They're very dynamic, et cetera, et cetera. What I'm exploring today is kind of a little bit, where are we in the middle? And how do we decompose a complex system using a little bit of both? So that's the game I'm trying to look at today. The first use case is financial reporting, or analysis based on financial reports. So what are corporate reports? This is a corporate report for a large European energy company. It has about, it has about 400x pages. Corporate reports, I looked back into the history, and unless AI hallucinated, the first kind of corporate report started about 300 years ago in France. And they remained steady in size for a couple of hundred years until they started growing just a few decades ago, largely because of the regulations surrounding, including other things, not just balance sheets, right? So a lot of sustainability, environmental, social governance, and so forth. So now the average corporate report for a public company is over 200 pages. Now, apart from the burden of creating these reports, it's actually interesting to use as a source. So if you're a financial analyst or a sales rep at a large bank, you might want to sell financial services to some of these companies, and you can actually find information in these corporate reports. So you can kind of look into page 408, and you can find the company's exposure and hedging attempts against interest rates fluctuations or currency fluctuations. And based on that, you can kind of figure out, well, maybe we can sell them something, essentially. So some of this is simple to extract, things like company name, reporting year, where's the headquarters, what's the total revenue, etc. Some things are a little bit more complicated. What is this company's exposure to risk for currency, interest rate fluctuations, price fluctuations of commodities, etc.? And what types of complex financial instruments can we recommend to this company? So the simple stuff is data extraction, or at least it's simple now with LLMs, because you can find revenues, the name of the CEO, all these kinds of single fields all over the place. Occasionally, you might even find, you'll find a lot of duplicates often, sometimes inconsistencies, but you can find and sort that out. It's not too hard. The more complex is, well, what do you do with a complex financial table? As it happens, this part of international financial regulation has not been standardized. So the way they present many of these more complex things are not done in a standard format. The old approach I would have taken maybe 10 years ago to sort this out or to do something analytically from these tables would be based on normalization. I would have said, well, let's normalize this across all companies. Let's find a certain way of modeling this. Let's build a database schema. And then once I have that schema, I can do my analysis. And there's actually in this industry, there's companies, Bloomberg, S&P Global, FactSets, and many others. The business model of these companies is to kind of do this normalization and provide dashboards built on these databases. So, but if you buy their data or you normalize yourself, then you can of course write rules or decision table based on this, and do your recommendation through business logic that you've defined declaratively. The drawback of this is, of course, right, it's a complex task to normalize this stuff. Whatever normalization you choose is going to be static, and it's going to be relatively shallow because it's just too complex. And of course, you're missing out on all the surrounding commentary that resides in text outside of these tables. The new approach we're taking for this particular use case is that we take the corporate document, we parse it, and that means we kind of separate the different pieces of the document. We're separating text from titles, headlines, diagrams, and tables into their pieces. Then we take these pieces and if they are a table, we convert it to a structured format. If it's just text, we keep it as text. We add some metadata and description to certain things. The difference here is that we do not normalize across companies here. So the table from the document, it retains its schema as it is. We just create a markdown or a CSV version of it, plus retaining the image of it as well. Once we have that, we start our basically agentic RAG-based approach. We based on your question or your prompt, we retrieve pieces from the vector database, including these tables. We run it, we add it to the context, and we produce our results. In this case, a recommendation of what to present to this company. We might want to do this agentically, meaning we use an iteratively prompt reformulation approach to make sure we get good retrieval results with good accuracy. And if all this goes well, you can see basically we are able to make recommendations based on information found in the tables. So that's the general approach in this use case. I wanted to I'll use this kind of picture for the other two use cases as well. I wanted to just sort of show what do we actually structure versus what do we keep in its original source form. So the basic stuff we structure, like the company name, ID, stock ticker, reporting years, and things like that, because that's useful as a high-level database for screening. If you only want to look at companies with a certain revenue or certain international exposure, you can screen first. Some things we keep hybrid. So the high-level revenue is kept kind of in a structured database, but the detailed breakdown over years and quarters and products we keep in its raw table form. The same thing for debt, profit, risk exposure, and all these kinds of complex financial instruments, swaps and futures and options. We might have a summary in a database, but the details are kept in its original source form. So we have basically a combination of, we have one database, these are structured, and we have one on the left-hand side, which is more of a, vector database with the extractions of the reports. So that's kind of like it's a mix, right? Some things is purely structured, some things is purely unstructured, and then we have some glue in between that connects the two models, if you will. So that was the first use case. The second use case is quite different. We're now in the area of high-tech manufacturing. And we're specifically around the B2B partnership and collaborations between companies. So here you have one company is trying to produce a phone or some other electronic gadget. This company wants to partner with another company to do the testing and prototyping or the design or the manufacturing of this component. These B2B partnerships are quite complex because you have specifications, you have data sheets, lots of international standards and regulations that you need to adhere to. So this is a very document and labor intensive process. Complexity on the document side, complexity on the policy side, lots of manual processing and operational friction. When I first wrote this abstract back in June, I was thinking I want to focus on the middle part of this high-tech process, which is more of prototype manufacturing and testing and so forth. I'm going to do something different today, and I'll tell you why. The middle part here is interesting because what you're faced with is you have these specifications including hardware diagrams and lots of tables and lots of values. And from that, you want to kind of extract information so you can feed it into these testing machineries. And these testing machineries have very rudimentary, old-fashioned UIs, but it's basically a data extraction task. It's complex and hard to do, but it doesn't really help me in what I want to talk about today. So what I want to talk about instead is actually the upstream part of the high-tech process, which is actually starting with the RFPs. So when you first trying to form that partnership, can you test or design or produce these gadgets for me? You usually issue an RFP or a tender with parts of the specification already defined. And then you start kind of a negotiation. So the traditional approach to handling this thing, and this is not just in high tech, you see a very similar situation in the software business and many other industries. You have a buyer generating an RFP, issuing it. You have some suppliers picking it up, deciding whether to respond. If they want to respond, they need to extract all the requirements and generate responses for all of them. Today, traditionally, this is very, very manual. What's happening over the last 5, 8, 10 years is that we're starting to get software that does this, right? RFP response management tools. They basically help you doing the requirement extraction, decide on whether to bid or not, help you with some consistency checking, and ultimately also to generate the response. So there's actually, within this scope here, there's a bunch of decisions, right? Should I bid or not on this on this RFP? How do I extract and assign requirements to people? How should they craft the responses to these requirements? Who are the reviewers and the approvers? How do I decide on the pricing and the terms for my offer, etc.? So there's a bunch of decisions within this broader scope. The old approach, pre-Gen AI, because this started a little bit earlier actually, was basically process orchestration plus manual work. So you would, there we go. So you would basically, you would have some orchestration of who gets assigned what requirement, who is the reviewer of that once the draft has been done, etc., etc. But otherwise, it was largely very manual. With Gen AI now, you basically have AI as an assistant for doing a lot of stuff. And I'm going to show you just a few kind of features that you will typically find and what they can do for you. The first part is requirement extraction, because what you typically get from the buyer is a PDF document. So you want to extract requirements from this large document. And these documents are often 50 to 500 pages, depending on industry and domain. And usually hundreds or a few thousand requirements in total. So you want to use AI here to extract the requirements. So you can put them into a regular database. And now you can kind of search and filter and assign and orchestrate the process on top of these requirements. So that's just this extraction of the requirement is kind of step number one. Then, of course, you want to generate answers to each individual requirement. And here we use LLMs to generate answers from a knowledge hub. So think retrieval augmented generation plus some fancier tricks, and you have a knowledge hub that you can use to generate an answer to a draft answer to each individual requirement with some citations from the knowledge hub so that the user responsible, the expert responsible for this requirement can validate the response and so forth. The second thing also, in many domains, especially in high tech, you want to reuse diagrams, pictures, images in your responses. So we have basically an AI-based natural language semantic search to find related images from your knowledge hub, so you can include that into your responses. And the third thing I'll show is more reusing of prior RFPs. Similar here, in most organizations, the traditional way of responding to a new RFP is to take an old RFP and see one that hopefully matches quite closely the new one. And then you try to reuse as much as possible. With AI, you can do that at a more granular level, because you can upload and ingest a bunch of prior RFPs. And then we use AI to extract the individual questions and answers from that RFP, store it, and then we can again use semantic natural language search to match a new requirement from a new RFP with good matching responses from prior RFPs. There's another 5, 6, 7 kind of AI-infused capabilities in this process to support these decisions, but this was just to take a couple of examples. And again, in the end here, what we end up with is a kind of a hybrid model where parts of our system uses structured data, the list of requirements, the timeline we extracted from the RFP, the response process, the whole routing, the process around routing, reviews and approvals, classic kind of BPM stuff. On the hybrid side is that the requirements have some structured components, like the metadata, who's the owner, who's the reviewer, etc. But the actual response to the requirement is, of course, stored as text, right? So this is some hybrid stuff. Similar also with prior RFP questions, the overall scorecard, etc., is typically like a hybrid thing. But then you have lots of content and lots of actions that are done purely on the document side of things. Summarization of the RFP, extraction of the requirements I talked about, and a bunch of other stuff. And all that things is just done using unstructured AI. So again, you have a mix underneath of unstructured data and structured data. And depending on the task, what's most suitable, you kind of pick the right thing. The third and final use case I'll dive into is, again, very, very different. This is higher education, adaptive and personalized learning. And just to give the backdrop of this one a little bit. So there's been lots of work over the years, over the decades around, automatic, intelligent tutoring and so forth. But also over the last few decades, a software category called learning management system evolved. And the idea is here you can capture all the content and activities around that the student needs access to. So it's a little bit of an interface, if you will, between faculty, the professors and teachers, and the student. So in these learning management systems, you have the learning activities, assignments, projects, formation of groups, assessments and quizzes, and so forth. You have the course material, right? The case studies maybe, or the videos and the articles and so forth, slide decks, of course, from the professor. You have also a representation of the student, the so-called student model, and that is, how is the student tracking? What was the score and the grades on the quiz and so forth? And what type of learning profile do they have? Maybe what language do they prefer, and simple things like that. And finally, you also have these LMSs have attempted to do interaction and collaboration inside their platform. So there is messages, there are forums, collaborative workspaces, and so forth. And sometimes gamification, right, to increase the motivation. From a process and decision management perspective, some of these LMS systems has a little bit of processes and decisions, right? There could be decisions for recommendations. It could be processes for, the assignments and the projects and so forth. But largely these are, I would say, see them as data stores. What's happened over the last few years, the first thing that happened was that, well, external tools, especially WhatsApp and Discord, they started to attract some of the use cases around sharing, collaboration, the social interaction between students, kind of pull that out of the LMS, or at least offered an alternative to the LMS owning those use cases. So what happens often now is that the students will just the first day of the class, someone will set up a WhatsApp group, and then we just all invite each other, and the chat will happen there. The questions and the sharing of material, the tips and the tricks before the exam will happen there. And this started, I think, 4 to 8 years ago. I'm not sure exactly, but this has been around for a number of years, right? The second thing that happened a bit more recently is, of course, that a lot of the use cases around writing, ideation, studying, doing research moved out to ChatGPT and similar tools. So what's happened now is that often students will just take the course content, download it from the LMS, and just plug it into ChatGPT or something, and have their tutoring or have their ideation, the writing of the essays, etc., done in those environments. Right. So this in a way is great because they get better user experiences outside the LMS, right? Unless you're an LMS vendor, of course. But it doesn't come without drawbacks. And one drawback on the AI side is that once you step out of the LMS and into ChatGPT, for example, you're missing a lot of context. You know, the ChatGPT doesn't know really what the student's identity is, their profile and preferences. There is no awareness of what program, what course is the student taking, what the schedule is or deadlines. ChatGPT and similar tools have started now with some memory, but it's not dedicated to memory around the learning. It's much more generic than that and not as great yet. And finally, the outside AI tutoring tool that has no concept, doesn't really track well what things the student has learned versus are struggling with. And by the way, I've mentioned now ChatGPT as an example, but there's also a lot of tutoring bots that are specific for learning at various levels, right? So it's not just ChatGPT, but any kind of external tool. So this project, what we set out to do is that, hey, we actually want to have a, AI-based personalized learning experience, and it should be student-centric, and it should work cross-time, cross-course, and cross-tools. That means that it should keep a memory over time, days, weeks, months, so that it knows and tracks what you are learning. It should also work across multiple courses, potentially, so that it's more of a student-centric rather than course-centric learning experience. And finally, it should work across multiple tools because there's no clear single winner, right, for learning that everybody has agreed upon. So it should work across ChatGPT potentially and many other specialized tutoring bots. So that was the idea for this project. I was going to show you a little bit here, but this is a snapshot of parts of what has been done in these things. So you have a learning environment, you have personalized quizzes, you have an interactive coach that you can talk to across courses or across learning activities. And you also have a kind of real-time voice dialogue that is tailored for specific learning activities. So if you want to have a dialogue or an interview format around a specific concept, you can engage with this voice dialogue bot. And to make this work, there's actually a bunch of decisions underneath. And it's kind of, if you think about it, it's the professor or the faculty here who wants to, in some ways, orchestrate these learning activities and make them personalized for the students. And AI acts away as a proxy, as a facilitator between faculty, between the professor and the students. So, and the decisions have to be made pretty dynamically here. What topic should this particular student work on right now, given the learning progress he or she has had? What content should we show and how? What's the right interaction mode? How do we engage? How do we motivate? How do we give feedback? And how do we even grade, etc.? There's a bunch of kind of small decisions that need to be made here that underpins this learning experience. And one of the key things we did underneath is to have a memory that stores and helps the AI facilitate that thing. So the last thing I'll do here in this example is just talk a little bit about that memory. The memory is initial, at least in this, it's part of the memory, I should say, is just transcripts of all the interactions you've had, the student has had with the tutor, of course, right? Whether it's an AI voice dialogue or text conversations, etc. So the transcripts are, of course, the input, and those are stored. But then we use those transcripts to extract and create and update a knowledge graph. So we create entities and edges based on the transcripts from the interactions between the AI bot and the student. This can be creation and updates of the graph, but it can also be fact invalidation. So for example, if I have a conversation about numerical analysis and it looks like I am really competent in that topic, then there might be an edge created here that says, Gregor is competent, understands at depth numerical analysis. If later on I have another conversation where I really flunk these questions, I really show evidence that I do not understand numerical analysis at all, well, that might actually invalidate the fact that I know numerical analysis, or at least reduce the strength of that knowledge. So that's the kind of the graph construction, the graph update process. And once we have this graph, of course, this gets reused in future voice dialogues and text conversations. And it's also get extracted and stored as part of the learning model, the student model, right? The strengths and weaknesses and the learning progress of the student. So the graph is kind of quite at the center of this memory, supplemented with the latest conversations and transcripts should we want to use them. And the way this graph construction works is essentially we take the transcripts, whether it's a dialogue, a chat, it can actually be actions as well, such as your results on a quiz. So we take those transcripts, they are divided into episodes, and the episodes ignore all the chatter, the welcome message and that kind of stuff, and it divides into separate episodes that cover different topics, and then these episodes are processed individually to update the graph, right, in some way or form. So the graph is quite central to the AI memory that supports all these kind of small decisions about how to interact with the students dynamically. And again, if you look at what we end up with as a system as a whole, we have some things that are structured, right? The course structure, who has access to, who is enrolled in what course, how far progress have you made on your quizzes or learning steps. A lot of that is structured, traditional database, structured data. Some things are hybrid. The student profile will have something, classic model stuff like my name and my email, of course, and things like that. But my strengths and weaknesses and learning progress will be typically stored as text. Then you have a bunch of activities that I talked about, the interactive coach, the personalized quiz, and so forth. That is, of course, unstructured, handled by the LLMs. And in the bottom, then you can see, again, we have this kind of mix of unstructured data and structured data in the LMS. I do see the graph here as a structured representation of knowledge, of course, right? Complemented in the student memory with the transcripts themselves. So these were very rapidly three kind of use cases, right? They're very diverse. They're different in their role. The decisions are different granularities. But I also wanted to, let me get 1 second just so I can see. I'm missing the chat window here. I want to see if I can get that back again. Why can't I see the chat window? Apologies for this. There we go.
No questions so far.
No questions so far. Okay, good. Let's, then I'm just gonna, there we go. Let me try and take a step back and just summarize some of the learnings with this and see if I can give you my perspective on some guidelines here. This is a really crude beta version of how I have come to think about when to model and when not to model. The first thing is, and this is very much the prior conversation as well, anything that needs control, that needs determinism, and currently also that needs speed or low latency, I would model using traditional mechanisms, right? Data models, business rules, whatever you, predictive analytics, whatever you want. I would also model separate anything that has to do with data security and data separation. That means, of course, you know, the logins and the access rights and that kind of stuff. I would also keep, you know, obvious. This might sound obvious, right? But I would keep course content separate between courses. I wouldn't mix those into the context window or into the RAG, right? Makes no sense. So anywhere where you want to have separation, or you have security or determinism, accuracy, I would model that using traditional mechanisms. That doesn't mean the whole system needs to be modeled like that, but the pieces of the system where you have such requirements, I would model those in traditional ways. But for everything else, I would just try LLMs. Anything around analysis, generation, extraction, yes, also reasoning, understanding of documents. I would basically just start with, let's put that document or pieces of that document or whatever it is into the LLM and see what LLM plus RAG plus agentic can do for me. So that's kind of step number 2, and then observe how that goes. What is the accuracy? What is the reliability? Is it fast, etc., etc.? Am I happy with the output? Then I would take a step back. If I'm not happy with that, the third thing is then to impose some structure for better retrieval. That means I can have a tree or a knowledge graph or some structured database to help me to retrieve context more accurately before I feed it into the LLMs. Typically, it means I'm not just relying on a vector database for retrieval. I'm complementing that with some other retrieval mechanism. And yet, just give a couple of examples. For the graph, well, I think the learning example is a good example where a graph can be useful. It's decent at representing knowledge. Let's say I'm trying to use the product documentation. So you imagine a regular big product documentation where you have versions of the product documentation, you have chapters, sub-chapters, sections, etc. You might want to represent that as a tree, because if you represent that as a tree, your retrieval mechanism before you build the context for the LLM, you can then go up and down the tree and kind of get some chunks in the surrounding, in the neighborhood, and that can be quite helpful. And of course, for the regular databases can be great, right? To keep separation of stuff and to do regular queries to build the context. This is of course very helpful and natural if you're connecting your system to a CRM system or ERP system or anything like that. So that's kind of my starting point. Now, you might want to iterate through this, go back and forth, but this is just at a very, very high level. I'll round off just with the perspective and a little bit where I started. I think it's a good time we're in because it's a little bit of a win-win situation. We now have a tool that we can use to understand and analyze and process types of content we couldn't process before, right? And it's not just unstructured text. One of the biggest things I would say this year has been the ability to read tables and graphs and charts. Today, you can actually, with the good LLM, get a structured representation of a line graph or a bar chart and things like that. So our ability to understand this unstructured content is much better than before. And as I said, we now have two choices. You can either do this design time approach where our traditional deterministic declarative models can just become better, more refined, more precise, because it's easier for us to design time, craft more complex data models, larger process and decision models, etc. So that's one approach. So that's a win in itself. And on the other hand, we can basically just do direct processing of things we couldn't do before. So that's what I think of as a tug of war, right? When we're building these systems, we have to decide on a case by case, which way do I go? Do I go execution time or, AI, Gen AI execution time with the characteristics of that? Or do I take a traditional method just better because I'm now able to use Gen AI at design time? That's all I have. And I'm open to any questions, comments.
Okay. Thank you, Gregor. I need to say that in last 2 years, this is the first time when I see very specific use cases about using Gen AI. It's not general statements, but it's very, very specific, and that's what I really like. And we do have a question from Alex. You can read it in the chat, or Alex, you can unmute yourself and ask this.
Sure. So thank you for the presentation. It was really, really interesting. My question is that I was interested on the high-tech manufacturing RFP use case. And so kind of when I think about that use case, I mean, I think of it as the goal of the RFP is to produce a strong proposal while helping to automate the process. And I was just kind of curious, you could always have that unintended consequence that the quality may decline if you don't have the strong guardrails in place, right? You could have, wrong content, or it gets outdated, or you could have, the stakeholders over time get lazy and they just click just to kind of get the exercise over with. But and then over time, right, that you could degrade the quality of the RFP. So I was just curious, what is your point of view in terms of how or are you modeling for quality of the RFP?
Yeah, I think the practical answer, and this is very practical, it's just a combination of things. And I'll mention a list of things, Tracy, that collectively helps you keep quality up. Number one is reuse of prior answers. In some cases, in prior RFPs, you will reuse answers. Sometimes you might have pre-approved, validated answers, for example, from legal or from finance, etc. You're not allowed to tweak them. So that's one way, right? They're pre-approved, they're static, you can't change them. The second part is, of course, the reviewal process, right? So you'll have a process as a scaffolding around that. So if the person drafting the answer to a specific requirement is a little bit sloppy, right? Just trust the AI, doesn't check the citations, hopefully the reviewer will catch it. So that's step number 2. Step number 3 is you can actually, of course, use AI to judge the quality of a response. You can even have separate models or at least separate prompts to do that. So one thing we can do there is that you can ask the AI, judge the quality of this response versus the requirement post, right? So it's a qualitative feedback, AI based. And then the fourth thing I'll mention is usually in an RFP, you'll have a scorecard. And this is on what dimension are the responses going to be judged. So usually you have price, functionality, company stability, whatever, service and support, etc. Right? So you have a bunch of dimensions, and you can then have an AI-based scoring mechanism that looks at the RFP response holistically, cross all requirement responses, and judges, are we ticking all the boxes on these scorecard dimensions? And then so I guess all of these are essentially variations of humans in the loop. I'll put it that way. It's no way around it. These are, and it's not just the fact. The problem is not just that these are probabilistic models, etc. The problem is actually more often in the knowledge hub, right? That the knowledge you have gathered to support the AI isn't sufficient or isn't comprehensive enough. But I think in essence, it's basically human in the loop. The AI can help the humans, right, to discover poor quality responses, but in essence, it's human in the loop, I think.
Yeah. Thank you.
More questions, please. Okay. Gregor, you did not say, you did not put any URLs or links where we can read more. If you can put this in chat, it would be very helpful.
I will do that. If you download the PDF, you will find the links to the website and so forth, right? But
yes.
I'll put a link here as well.
Okay.